Welcome YouTubers to another episode in my Grammar Hero series. In today's video, we're going to continue talking about all the factoring techniques with which you need to be familiar in order to do your best on the Armed Services Vocational Aptitude Battery, notably on the Mathematics Knowledge Subtest. More specifically, I'm going to talk about factoring quadratics when the leading coefficient is 1 today. As I did for yesterday's video, I'm going to include a link to this factoring guide in the description of today's video in case you find it helpful to look at this as we go through this series on factoring. All that said, let's go ahead and get started with some practice problems. And before we do get started factoring, I do want to try to tie today's video in with yesterday's video. Yesterday, as you may recall, I talked about using the quadratic formula. And if you watched that video, you may have noticed that a lot of the work that I did in that video was very tedious. Again, we had to use the quadratic formula to solve for the given variable. Let me stress this. The quadratic formula, as well as today's factoring technique, is used in solving for variables in quadratic equations. In case it's not clear yet, a quadratic equation is of this form: ax squared plus bx plus c. That is to say, you can use either the quadratic formula to solve these, or you can use factoring techniques. The biggest difference, as you'll see in just a minute, is the quadratic formula takes a lot of work, whereas factoring usually makes these problems take about 10 or 20 seconds to solve. Similarly, let me stress this before we start with number one. We're factoring quadratics with a leading coefficient of 1. That means this a value is going to be 1. And since anything times 1 is itself, the a value of 1 is simply just not written in mathematics. So again, what I just said is we have x squared times 1. Anything times 1 is itself, so x squared times 1 would be x squared, and therefore that 1's typically not going to be written in these equations. Let me start by solving number 1 with the quadratic formula to show you how that works, and then we'll do it with factoring to show you how much quicker that is. So again, in case you forgot, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. As we did yesterday, we have to identify our a, b, and c values. Again, as I just mentioned, if a is not written, we assume it's 1, so 1's going to be our a in this case. B, of course, is going to be 7, and C, of course, is going to be 6. Now let's just plug those in and use this formula to solve. Again, B is 7, so inside that negative, we're going to plug in 7, plus or minus the square root of B squared, so 7 squared minus 4 times A is 1, times C is 6, all over 2a. A is 1, so this is 2 times 1. Let's keep working this out. Negative times positive 7 is just going to be negative 7, plus or minus the square root of 7 squared is 49, minus 6 times, or 4 times 1 is 4, times 6 is 24. And again, that's all over 2 times 1, which is just 2. So now we're just going to keep reducing this, and I'm going to skip a step here because I don't want to do, I'm going to do this math mentally. Again, I'm going to do negative 7 plus or minus the square root of 49 minus 24 is 25. Again, that's all over 2. Let's keep working this out. The square root of 25 we should know is 5, so negative 7 plus or minus 5 over 2. As you may recall, we split this into two solutions, namely negative 7 plus 5 over 2, as well as negative 7 minus 5 over 2. And we solve accordingly, starting with the top one. Negative 7 plus 5 is negative 2. That's over 2. Negative 2 divided by positive 2 is negative 1. Negative 7 minus 5 is negative 12 over 2. Negative 12 divided by 2 is negative 6. So using the quadratic formula, we solved for the variable x, and as we can see, there are two solutions, notably negative 1 and negative 6. As you can see, that was a lot of work. It took 1, 2, 3, 4, 5, 6, 7, 8, 9 steps, and I even skipped a step. So this took 10 steps to solve. Okay, so now let's talk about the more efficient way of solving quadratics, and that's with techniques known as factoring. Solving or factoring quadratics with a leading coefficient of 1 are always going to be of this form: x times x in parentheses. And that x could be whatever variable you're given. As you can see down here, we're going to have p, so we'll put p in place of x. But they're always going to be in this form. And now it's just a matter of asking yourself this: what two values can I find that that have a product of 6 and add to 7? So we're looking for two values that do that. And again, in case you haven't seen this in a while, some people find it helpful to make a little T-chart so they can keep track of their work. The goal is to be able to do this all in your head, okay? So again, to factor this, we're asking ourselves, what two integers can we find that have a product of 6 and add to 7, positive 7? Well, 6 times 1 does multiply to 6, and 6 plus 1 does multiply to 7. So these two factors will work, and in light of that, we just plug them in: x plus 6 and x plus 1, and just like that, we were able to factor this equation. Now that said, on the ASVAB, instead of just telling you to factor, you're gonna be given the instructions to solve. In this case, you would be told to solve for x, in which case, just like we did down here using the quadratic equation, we would break these two apart. We would set x plus 6 equal to 0, and then we would set x plus 1 and equal that to 0. And then we would just solve for x in both cases. In this case, we would subtract 6 from both sides. 6 minus 6 crosses out. That leaves us with x equals 0 minus 6, which is negative 6. To solve this one, we would subtract negative 1 from both sides. 1 minus 1 crosses out, leaving you with x equals negative 1. Okay, so here are our two solutions. So again, on the ASVAB, you're going to have a choice as to how do you solve for these variables that you're given. As long as you recognize that this is a quadratic equation, and therefore you must use either the quadratic formula or a factoring technique to solve it, you'll be in good shape. But it behooves you to use a factoring technique, since as you can see, with a little mental math, you can solve this one in a matter of seconds, whereas you solve these with the quadratic equation in terms of minutes. Okay, so I just wanted to point that out to start today's video. All right, so let's move on to number 2. Again, we have x squared minus 7x plus 6. This is very similar to the first problem. Everything that we do today is going to be in this form: x times x in parentheses. And again, we're asking ourselves, what two integers can we use to factor this that have a product of 6 and a sum of negative 7? Okay, so let's make a little T-chart if we need to. Again, we're looking for two factors that have a product of 6 and a sum of negative 7. Okay, so let's think about what we're going to do there. Well, I know negative 6 times negative 1 equals positive 6. Again, negative times a negative is a positive. And in addition, I know negative 6 plus negative 1 does equal negative 7. So these are going to be the two integers I'm going to use. That is negative 6 and negative 1. And of course, on the ASVAB, instead of being told to factor this, you'll be asked to solve for x. So in order to do that, we're going to split these apart and set them equal to 0. So this x minus 6 is going to be set equal to 0. And similarly, this x minus 1 is going to be set to 0. To solve for x, we're simply going to add 6 to both sides. This crosses out, leaving us with x equals 0 plus 6, which is 6. Add 1 to both sides. Negative 1 plus 1 is nothing, so this leaves us with x equals 0 plus 1, or just 1. And again, just like that, using basic factoring technique and some mental math, we were able to solve this one. So let's do the rest in this video using factoring techniques instead of the quadratic formula. On number 5, you may get tripped up, so here's what I'll say. For the rest of the video, try to pause the video, factor these on your own. Play the video to see if you and I came up with the same solution, and then that will be a good review of factoring for the ASVAB. These type of equations probably make up 90% of what you'll see on the ASVAB. So if you can get these down, you'll be in good shape for the ASVAB. But that said, let's move on to number 3. Again, we're using the variable p, and we're given the equation p squared minus 4p minus 45. So we know the solution is going to look like this, p and p. And again, we want to find two factors that are going to have the product of negative 45. So product in this case is going to be negative 45. And the sum of those two integers is going to be negative 4. So the sum is going to be negative 4. Again, we're looking for two integers that satisfy those requirements, that have a product of negative 45 and a sum of negative 4. Again, I pulled those right from here. Let's think about that. Well, I know negative 9 times positive 5. Again, a negative times a positive will give you negative 45. And negative 9 plus positive 5 will also give you negative 4. So those are going to be the two factors that work. So I know it's going to be negative 9 and positive 5. Again, on the ASVAB, you'll be asked to solve for p in this case. So to do that, you're going to set these equal to 0 separately. Negative 9, or p minus 9 equals 0, as well as p plus 5 equals 0. And then you're just going to solve for p accordingly. That is, you're going to add 9 to both sides in this one. Negative 9 plus 9 crosses out, leaving you with p equals 0 plus 9. 0 plus 9 is just 9. And for this one, we're going to subtract 5 from both sides. That's going to cross out, leaving you with p equals 0 minus 5, or negative 5. And just like that, we solved that one. Again, there's two ways to check your work. Again, since we chose these two factors, what we could do is FOIL, that is, expand this to see if it equals the original equation. And that would look like this, p minus 9 times p plus 5. Again, we're going to FOIL this or expand it. To start, I'm going to do p times p and then p times 5. So that's going to be p squared plus 5p. Then I'm going to do negative 9 times p and negative 9 times 5. So that's going to be negative 9p minus 45. Again, we're going to combine like terms, so this is going to be p squared. Negative 5p minus 9p is negative 4p. Again, that's minus 45. And as we can see, by expanding this, we do get the original equation, which means we did our work correctly. Okay, so let's go ahead and do number 4. Again, we know the answer is going to be in this form, b. That said, we're looking for two factors that multiply to positive 12 and then add to our two integers that multiply to 12 and add to negative 8. So again, we're looking for the product of those two integers to be positive 12, and the sum of those two integers to be negative 8. If it's helpful, you can make yourself a little t-chart. Again, two factors. Let's do negative 6 and negative 2. Again, negative 6 times negative 2 is positive 12 insofar as a negative times a negative is a positive. Negative 6 plus negative 2 is negative 8. So we know these two factors will work. So it's going to be negative 6 and negative 2. Again, on the ASVAB, it would say solve for b in this case, and you would have to know that you can either use a quadratic formula or a factoring technique to solve this one. Either way, you're going to have to set these equal to 0, b minus 6 equals 0, and b minus 2 equals 0. To solve this one, we're going to add 6 to both sides. Negative 6 plus 6 crosses out, leaving you with b equals 6. And to solve this one, we're going to add 2 to both sides. Negative 2 plus 2 crosses out, leaving you with b equals, and that's a bad b, so let's rewrite it. B equals positive 2. Okay, so that one is solved. Let's go ahead and move on to, and I think I said number 5 is the one that's going to trip you up. It's actually going to be number 6. So let's go ahead and work on number 5. Again, this is going to be x and x. We're looking for two factors that have a product of negative 8 and add to negative 7. Let's go ahead and use our chart if we still need to. Once we get past number 6, I'm going to stop using the chart. We should be able to do it mentally. Again, they have to have a product of negative 8 and sum of negative 7. We're looking for two integers that satisfy those requirements. Let's see. What about negative 8 and positive 1? Again, negative 8 times positive 1 is negative 8. Negative 8 plus 1 is negative 7. So those do meet our requirements. So we know our two factors are going to be negative 8 and positive 1. Again, on the ASVAB, instead of being told to factor this, you're just going to be told to solve for x, which is going to prompt you to set these equal to 0 and solve for x accordingly. So we're going to set x minus 8 equal to 0, x plus 1 equal to 0. We're going to add 8 to both sides to get x by itself. This is going to cross out, leaving us with x equals 8. We're going to subtract 1 from both sides to get x by itself. 1 minus 1 is nothing. This leaves us with x equals negative 1. And just like that, we solve this one. So let's go ahead and move on to number 6. Again, more often than not, the form of these is going to be k. And in this case, we're looking for two integers that have a product of negative 5. So this is going to be multiplication and add to positive 5. So if you want, you can set up a little t-chart. Again, the two integers are going to have a product of negative 5 and a sum of positive 5. Now, in this case, you might say, well, one's going to have to be negative, one's going to have to be positive. As we know, 5's a prime number, so it's going to either be negative 1, 5 or negative 5, 1. Negative 1 times 5 certainly is negative 5. Negative 1 plus 5 is positive 4, so that does not work. Negative 5 times positive 1 is negative 5. Negative 5 plus 1 is negative 4, so that doesn't work. So at this point, we're saying to ourselves, well, we can't factor this one quickly using the technique that we just learned. So this equation is either 1, not factorable, or 2, going to require us to use the quadratic equation to solve it. Again, if you were just told to factor this using this technique, you would say this is not factorable. But if we plug this into the quadratic equation, we'll see that this one actually does have some real solutions. So let's go ahead and do that. Again, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. And we know our a is 1 in this case, our b is going to be 5, and our c is going to be negative 5. Just plug those in accordingly. Again, we have negative of 5 plus or minus the square root of b squared. That's going to be 5 squared minus 4 times a, which is 1, times c, which is negative 5. And again, that's all going to be over 2a, and as we know, a is 1. So let's keep working this out. Again, negative times positive 5 is just negative 5. That's plus or minus the square root of 5 squared is 25 minus, again, negative 4 times 1 is just negative 4. Negative 4 times negative 5 is going to be positive 20. Again, that's all going to be over 2 times 1, or just 2. Let's keep reducing this. Negative 5 plus or minus 25 plus 20, of course, is going to be 45 all over 2. Let's keep reducing this a little bit more. We have negative 5 plus or minus the square root. And I'm going to break down the square root of 45 to be this. Again, the square root of 45 is the same as the square root of 9 times 5, which can be broken down into the square root of 9 times the square root of 5. The square root of 9, as we know, is 3, so that can be broken down into that 3 times the square root of 5. So in other words, this is negative 5 plus or minus 3 square root 5 over 2. And that would be our solution in this case. So the most exact answer we can give for number 6 is it's not factorable. That said, it does have real solutions, and those real solutions are negative 5 plus or minus 3 radical 5 over 2. Okay? So again, you have to be prepared to do both things on the ASVAB. ASVAB's either going to say factor or solve for. If it's solving for, you're going to have to get to this point. If it's factoring, you're going to say not factorable. All right, a couple more to do. Again, a squared plus 14a plus 48. Again, we're gonna set it up because we know what the solution's going to look like. It's going to look like that. And again, we're looking for two factors that multiply to 48 and add to 14. Let's think about factors of 48. Again, this one's not too easy because the factors of 48 are not straightforward. Again, we know the factors of 48 are 4 and 12. 4 times 12 will give you 48, but 4 plus 12 will give you 16, not 14. So that one's not going to work. What about 8 and 6? 8 times 6 will give you 48. 8 plus 6 will give you 14. So we know those two factors will work. So this is going to be plus 8 plus 6. Again, if we were told to solve for a, we would simply set these equal to 0. Again, we would subtract 8 from both sides. This would cross out, leaving you with a equals 0 minus 8, which is negative 8. And we would subtract 6 from both sides. This would cross out, leaving you with a equals 0 minus 6, or negative 6. Okay? Again, I'm not using the T-chart for these because at this point we should be able to do these in our head. Again, they're not too difficult once you get the hang of them. And again, this is the majority types. These equations are what you're usually going to see on the ASVAB. So if you can do these, you'll be in good shape for the mathematics knowledge subtest. So let's keep working on, let's work on number 8. We have n squared minus 15n plus 50. So we know that if this is factorable, it's going to look like that. We're looking for two integers or factors that have a product of 50. and add to negative 15. 5. Negative 5 times negative 10 will give you 50. Negative 5 plus negative 10 will give you negative 15. So we know this is going to be negative 10 and negative 5. And if we wanted to solve for n in this case, we would let these equations equal 0, n minus 10 equals 0, and similarly, n minus 5 equals 0. Let's add 10 to both sides. This crosses out, leaving you with n equals 10. Add 5 to both sides. This crosses out, leaving you with n equals 5. Okay, so that was that one. Again, these get pretty easy as you get good at the mental math. Again, we know the solution for this one is going to look like this if it's factorable. We're looking for, more specifically, two factors that multiply to positive 4 and add to 4. So 2 times 2 does equal 4. 2 plus 2 equals 4. So we know this one's going to be positive 2 or positive 2. Again, since these are the same, we know there's only going to be one solution, namely p plus 2 equals 0. Subtract 2 from both sides. This crosses out, leaving you with p equals negative 2. So the solution to this one is just negative 2. Again, there's only one solution. Finally, we have this one, x squared minus 6x minus 27. So we have x and x. And we're looking for two factors that multiply to negative 27 that add to negative 6. Negative 9 times positive 3 will give you negative 27. And negative 9 plus positive 3 will give you negative 6. So I know these factors are going to be negative 9 and positive 3. Again, set these equal to 0 to solve for x. Add 9 to both sides to solve this one for x. Again, that leaves you with x equals 9. Minus 3 from both sides or subtract 3 from both sides to give you x by itself. X would be negative 3 in this case. Okay? So again, in today's video, I just wanted to show you how to solve quadratics when the leading coefficient is 1. Again, you have a choice. You can either use the quadratic formula, or as I recommend, you should be comfortable factoring these. As I mentioned, factoring is much quicker and more accurate than using the quadratic formula. But in the event you get stuck on the ASVAB, on a problem on the ASVAB, just bear in mind you can always go back to the quadratic formula. So that's all I have for you in this video. Again, there's no real other way to teach you how to factor other than doing 10 or so practice problems. That said, I hope you enjoyed this video. If you like the type of content that I'm posting, by all means, feel free to subscribe to my channel. In addition, you can always leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.